talk is about Nikita, ostensibly, which is something that I named after something we have in Rubinius called the agent interface. So Nikita, I thought that went well together. But should have reversed those slides. What I'd really like to talk about is why I have never, ever, ever heard anyone say this, and I have never I've never stopped hearing about how Smalltalk has these fantastic tools and how Java has these fantastic tools. So I'm kind of a big picture person. I want to talk a little bit about a forest instead of some trees. We have lots of trees that we'll get to in a little bit. But I want to talk about some ideas because I want to know why nobody is quoted as saying that Ruby has really good tools. Usually what we see, and I apologize, these slides are totally fucked up. I don't know what the fuck show off does, but that did not look like that like 2 minutes ago. So bear with me. A lot of what we talk about with Ruby is something like this. Ruby is a beautiful language. It's my favorite language. I work really, really hard on Rubinius and RubySpec because I love Ruby and I want it to be the language that people can use. We talk a lot about how developers feel when we use Ruby. We like Ruby. Ruby makes it easier for us. It makes us happy. And when we look at something like Rails, Rails is a terrific framework. Whatever you may think about how Rails goes in this direction or that direction at one particular time, the fact is if you look on the internet, almost every single web framework out there either tries to differentiate itself from Rails or it tries to tell you that it's exactly like Rails. Well, if it's exactly like Rails, then why would you use the thing that's a knockoff of the real thing, right? So Rails has really redefined web development, and it's defined a huge domain that Ruby is used in, right? Ruby, at this point in time, is no longer just a language that people program in because it makes them happy, and it's not just a language for web application development. It's actually now pretty serious business. And when I say serious, I mean like billions of dollars serious, right? So billions of dollars is a lot of people's salaries. It's a lot of families' well-being. It's a lot of businesses' success. It's an entire ecosystem, right? So who here is paid to write Ruby? Okay, that's almost every single one of you, right? 4 or 5 years ago, that would have been much less. 6, 7 years ago, it would have been a couple people, right? So huge transition. Companies have invested in Ruby and they have bet on Ruby. I'm very, very happy to work for Engineard. Engineard has very generously sponsored a lot of work for Ruby. They sponsor the Rubinius team. They sponsor the JRuby team. Not just 2 Rubies. They sponsor still like maintenance of 1.8.6. So that's 3 Rubies. They sponsored a ton of development on Rails. They've sponsored development on Fog. They've really done a lot to foster Ruby as a community and the success of Ruby. They just recently opened an office in Portland where I've been for like 3.5 years. It's really beautiful. You're welcome to come, and we are hiring. However, if you look around here and you know and you've been in the Ruby community for a few years, there are people that aren't here today, and that's distressing to me. There are people that are leaving Ruby, and they're leaving Ruby for other languages, other systems. A lot of people are really excited about Node. A lot of people are really excited about Clojure and Scala, and these are all very interesting and fantastic systems. They offer almost nothing, I think, in this domain that Ruby doesn't. Recently, this polyglot word, right, has sort of become, in my perception, sort of the new liberal, right? It's like you want to be nice to everybody, so if you like that language over there and I like this language over here, we're all cool, we're all friends, it's all good. And who am I to tell you that your religion is not as good as my religion, that sort of thing. If someone was running for office and they basically made this argument like, hey, all the candidates are good, but I want you to vote for me, right? Would you vote for that person? I'll try to stop that. How's that? All right, so not only do we have these other languages that are pulling intellectual sort of mind share from Ruby, but we also have this sort of confusion often that the way Ruby has been implemented is confounded with the language itself, right? So MRI is the reference implementation, but it's not actually Ruby. It's one implementation of Ruby. And so when I deal with these sort of things, I get really frustrated because Ruby has some fantastic stuff, and if people are leaving Ruby for reasons that are not at all related to the language, but something related to the implementation, that's really frustrating. And damn it, you can't see this. So basically she's saying, this was a lot of fun to write, but it's really slow. Right? So she's disappointed, right? It's like she basically sort of bet on this thing. When someone's disappointed, then that emotion, they need to sort of work that out. And one of the ways that you kind of work that out potentially is by blaming. And so you're like, yeah, Ruby, blah, blah, right? So then we get to this idea, you know, I mean, business is not easy. How many startups fail? 9 out of 10, something like that? Oops. And business is really about customers, right? If you don't have any customers, you don't have a business. And businesses are constantly balancing that decision between fear that someone is going to steal all their customers and sort of greed of, oh my God, if I had all the customers in the world, I'd make this much revenue, right? So a lot of companies probably aren't choosing Rails in this sort of middle of the bell curve where it started out. Innovative companies were like, hey, I can deliver faster, cool, we're going to be innovative. Companies in the middle of that are doing it more along the lines of, oh shit, those guys are going to get to market before I can. What can we do? Use Rails. Okay, we'll get there, right? So that's a very different decision, because a fear-based decision is something that can be made very rationally, right? Versus a decision where somebody's like, I'm really excited about this, let's do it. Finally, developers are not paid to be happy. They are paid to make customers happy, right? And if the business needs, right, for the customer happiness and the developer happiness collide, guess who wins? I mean, just ask some Java developers that struggled through all that. So what I want to do actually now is I want to play, if I can, something for you guys that I think is critically important for us to sort of see. And I'm wondering if I'm going to be able to do this. Do I have to have my mic on the computer for this to pick up? Sound person? We'll find out.
My name is and I run the application services group at Twitter. So if you think of all of Twitter and try to decompose its business logic, we have users, we have tweets, and we have timelines that sort of comprises the entire app. My group runs all the scalable infrastructure around those three things. So we build all the architecture needed to take a tweet in, fan a tweet out. We have a couple thousand tweets a second come in. We need to fan it out to a couple 100,000 people every single time one of those come in. Those might be triggered by web delivery, SMS delivery, emails might go out. We might do Apple push notifications. There's a whole lot of things that go on within Twitter, and my group runs all of that infrastructure. So what I want to talk about is the story of like how we're moving from Ruby on Rails to the JVM. So this is Jack's first sketch of Twitter. Somewhere around 2006, we decided to build a website. So everyone knows what websites are. They're a collection of documents, usually served from a directory structure. They're either statically generated or dynamically generated. We have the standard REST-like commands on top of them. You're either going to do a get, a put, or a post. So that was Twitter in about 2006. And until recently, we started thinking Twitter more about a service. So people are generating events in real time all around the world, and we need to percolate those events through our system and act upon them in real time. So that means not just a couple thousand requests a second to get on baseline, but handle these big, huge spikes that come in. The name of our game is real time. That's the hardest thing that Twitter has to do and accomplish. It's not an option for us to deliver a tweet a couple of minutes later. Like, we really want to get that tweet out in a couple of seconds, if not faster. So along with an evolution of our service has come an evolution of our technology. So we are probably the largest Ruby on Rails website on the planet right now. Majority of our front-end traffic is still served from Rails. Like, we have Rails hitting a bunch of back-end services, composing all the responses back, and then returning them up into the cloud. But recently, we've been thinking a lot more about moving, and we have been moving a lot of our technology over to the JVM. In fact, this started around 2008. So 2008, we moved our queuing system, the system we called Starling at the time, to Kestrel. So Starling was in Ruby, Kestrel's in Scala. Around 2008, we acquired a company called Surmise, which handles search.twitter.com. All that infrastructure is on Java. And as we move along, and as my team continues to decompose the main Twitter application, we're rebuilding all those pieces of infrastructure on the JVM. And I'm going to try to go through a bunch of the reasons why we're doing that. So I have a slew of problems, and that's interesting formatting. I have a slew of problems on my team. First off, we have a huge number of concurrent connections coming into Twitter. Like on an off day, we're handling a couple hundred thousand requests a second to our infrastructure. We're pumping out a lot of I/O. If any of you has ever played with our fire hose, again, on an off day, you're talking about tens of megabits are coming out of our fire hose at any given time. All those being pushed out as quickly as we possibly can. And we have very few persistent objects. So that's basically the definition of a server workload. So the reason why I have a bird on the screen, mainly because every single project at Twitter is codenamed after a bird at some point, is we actually spent a long time trying to get Ruby to do what we needed to do. We patched the MRI. We actually built a whole new garbage collection engine to run within the runtime to make it faster and a lot more efficient for us to use to actually tackle these huge server workloads that we're getting. And we're going to continue to do this type of work. Like we're continuing to push Ruby as far as we possibly can because our entire infrastructure has been built upon it. But we're also looking for opportunities to go and join bigger communities, find more developers, use better tools, and just evolve in a direction that the world is going in a way that we know will work well. So for that, we're relying on the JVM. So my needs. We already talked about server workloads, but as I'm going through and decomposing my application, we actually also want flexibility in language. So we're starting to pull things out of what we call our monolith. So our statuses are coming out, our timelines are coming out, our users are coming out to their own back-end services. So we want to have flexibility in all the different axes we possibly can, and language is one of them. So as a lot of people know, we run Scala for the majority of our runtime back-end systems. So all our storage systems have a Scala layer on top of them that sort of handles charting. I'll talk about that in a bit. But we also have a lot of Java within Twitter itself. And in fact, Scala and Java are two first-class languages at Twitter. We support them both equally now. A lot of our runtime code, critical path code, is in Scala. However, a lot of our relevance engines, our search engine, our advertising systems, and a bunch of other things are being written in pure Java right now. And the new kid on the block within our infrastructure is running Clojure. So we've been experimenting and toying with running Clojure more and more in production. The beauty about all this is that my ops team gives me no grief because we simply deliver them jar files to deploy and manage as long as we give them similar ways to monitor and manage all that code. So what I mean by that is similar ways to look at garbage collection logs, similar ways to get stats exported from all our runtime services, similar ways to deploy them. Our ops team really, they have an opinion, but they don't care as much as to what the engineering team may be up to. So Clojure came around with our Backtype acquisition recently, and it's something we're going to start investing in more and more. So the last thing that I want to touch upon, and what's one of the biggest reasons that we're moving to Java, is it's a real concurrency model. I know that's a kind of crazy thing to say to a bunch of Java people in a room, but I'm coming from a world where we have not the best threading model on MRI inside the Ruby VM. So it means that we can't really experiment in the ways we want to, and some real performance numbers. Right now, a single request to a Twitter API takes tens of milliseconds. We run in a request per worker model, so one request comes in, is given to a worker to deal with. That artificially gives us a low QPS that we can handle, queries per second that we can handle per box. And it just hampers our growth. Our machine density is not as good as we think it could be. So we've been experimenting, and we've built a system we call Finagle finagles our generic RPC mechanism we've released open source for anyone to use to handle all the back-end traffic our servers can handle, as well as new incoming front-end traffic. We've abstracted away how to do asynchronous event-driven networking so we can just write beautiful and elegant code in either Scala or Java, or basically any other Java JVM language we choose. And one of these finagle servers can pump out tens of thousands of queries a second, doing the exact same thing that our Ruby machines can do. But, and I'll talk about this a bit later, we've changed our efficiency metrics because we've done something like this. So fundamentally, Twitter is a real-time and event-driven problem. We're trying to build a system that will react to the world and be able to scale as the world scales. As people talk about events, we want to handle them in real time. As one of the people who's working on the core infrastructure and manages a group of around 35 people writing the core infrastructure, we want to fundamentally rethink the way that we work on Twitter. So Ruby doesn't provide us the ability to do scatter-gather algorithms, for example. So I want to be able to have the ultimate flexibility in constructing timelines for users. So as a request comes in, I want to hit hundreds of back-end machines, compose responses back, and return in 50 milliseconds. And that's something I can't do in Ruby right now. In Ruby, like you can see some of our code, we literally have to go and hit every single back-end server in serial and to figure out what to do at the end with careful timeouts along the way. I just want to hit them all one shot and pull the results back. So fundamentally, the JVM gives us something that Ruby can't. So lastly, the things I trade in inside my infrastructure is I trade in RAM and CPU, I trade in bandwidth, and I trade in machine density. So RAM and CPU is obvious. We're building a bunch of systems that allow us to operate more as a cloud inside Twitter. So we can just simply launch processes into the data center and say, I need this much RAM, this much CPU.
Okay. You can watch the entire thing. The URL is in my slide. Essentially, one sec. Okay. So he said a couple of interesting things, right? I swear I heard him say beautiful and elegant code in Java. So I don't know if we want to take the rest of what he said seriously or not. However, a couple of things he did say is that Ruby, and he kind of distinguished between MRI and Ruby at one point, but most of it is Ruby. Ruby can't do scatter-gather because it has no concurrency. Ruby can't do good garbage collection. Ruby is not a suitable language for a near real-time complex system that has massive server workload. I don't know, like there's tons of Ruby on desktops, but I would guarantee that there's, well, I wouldn't guarantee, I would estimate that there are probably several times as many instances of Ruby running on servers around the world than they are on the people's laptops that are sitting in places and doing development. So two blaring black eyes for Ruby. If you see the entire thing, he basically says also that he can hire better developers if he goes to Java. So he hits on these four things, right? Garbage collection, concurrency, performance, and tools, right? When you deploy this stuff, you want to have good tools so that you can actually see what's going on in this VM. Yes, I am worried because while Twitter is one company, Twitter is a company that a lot of people looked at when they first started using Ruby on Rails. They're a company that other people are looking at seriously, and if you, they're a visible company. He gave that talk as a keynote at OSCON. OSCON is a big and very broad conference. There are people from all over the place that attend that. The companies that are making their decisions based on fear are going to be companies that say something like, oh my God, Ruby can't scale. It might get us there, but maybe we should use something else because we're going to need to scale. And of course they don't need to scale, right? It's one of those premature optimization things, but decisions based on fear are not always rational. So yes, I'm worried. I'm also worried because I live in Portland, and Ward Cunningham and Alan Worth-Brock, two, like way up here, pioneers of the previous generation. We sat down with them recently, and Alan pointed out that Smalltalk went from a language that was, widely used and only like maybe IBM ignoring it to a language that was near irrelevant within the span of about 18 months, right? So complex systems have inflection points. You can be going like this and suddenly go like this. You don't just go like this, that sort of thing. So yes, I am very worried. And one thing that's fairly true is that we're all still kind of kids inside, right? That's why Ruby makes us excited when we're having fun, that sort of thing. I don't want to see the sad day when people are basically told, no, you have to use a language that many, many people have said, this language is not for me, I don't want to use it. But someone else is making that decision, not you, because you can't deliver with the language that makes you happy. So, fucking slides. So if tools are the answer, right, what kind of questions are we actually asking? And I think the number one question is this: how do I understand this code? I need insight into my code. Ruby is a dynamic programming language. That means that a program that you write in Ruby is kind of like a class in Ruby. When you actually want to use an instance of a class, you have to instantiate it. When you want to run an instance of your program, there's actually real object with real types. Like this might be an array or it might be a string flowing through your program. So your running program is kind of an instance of this dynamically typed program that you expressed in Ruby code. Fear of the unknown is one of the most important motivators, I think, for people sort of running to something like static typing, thinking that it's going to give them some greater security. However, the type systems in complex statically typed languages can be Turing complete as well, which means that you can make the compiler not terminate, not just your program, right? So there's nothing in static typing that necessarily gets you some greater security, but it might suggest some security, and so people are willing to sort of take that because they're not examining basically their fear of the unknown. So the key for me for tools is how do we give people insight into their code, right? Thinking about like insight in code, I want to look at a couple of things, and this is intentionally reversed. Usually you should have a problem and figure out the solution, right? What I'm seeing happening is that we have a bunch of solutions and then we go looking for the problems. So these are the 4 things that I've just sort of picked out that have the topicalness, like how much they're being discussed, have kind of gone up and down. But there's been discussions about optional typing. We need to add optional typing to Ruby to make it faster. This argument is false. However, it doesn't stop people from proposing it over and over again. So Ruby is about behavior, right? It's about the things that it's how the objects in your program act, right? You send them a message. So sort of the idea of you are what you do, right? We call this duck typing, which I'm not a fan of that word, but it communicates the idea. But the idea is behavior, you are what you do. Classes, on the other hand, organize code. They are a tool that we use intellectually to manage complexity, right? The most important thing that classes do is they provide the encapsulation that's necessary so that an object can manage its state without something else getting in the way. So encapsulation is really super important, and classes provide that much more than anything else. There's sort of, I think, sort of taking this from Josh Susser's words, but basically there's sort of these 3 primary ideas in object orientation. Encapsulation, polymorphism, which means that you can name the method the same thing, and inheritance. But inheritance doesn't have anything to do with classes. Prototype systems use inheritance just as well as class-based systems. So I want to emphasize that classes are more a tool for us to think about code. There's something that concerns me even more than optional typing, and this is hidden typing. I'm going to call this hidden typing because I don't know what else to call it. It's basically this idea where we start imposing typing-like requirements on Ruby code, but they're not really visible. And I couldn't find exactly the right word to use for concealed, but it's essentially that Ruby can't participate. So these requirements are not in Ruby, and they may be either sort of undefined in the Ruby ISO standard, right? It doesn't actually say whether it's going to impose this requirement, or they're just not documented. And because they're hidden from Ruby, Ruby can't participate. So we have coercion methods like integer, capital I, integer Bing, or like float, this sort of thing. Ruby can participate in those sort of coercion protocols, right? They can't participate when we have something like this. Blah, 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 blah. Oh, if RB object is kind of, suddenly anything that wants to participate in something that is sort of float-like has to be a subclass of numeric, hidden in the C code somewhere. If you implement 2F, which this will accept, otherwise, you don't get to participate unless you subclass numeric. If this was Ruby code that we were looking at instead, many people would say, hey, there's a smell in this code. I see you're like hard coding something to numeric here. Why are you doing that? The real big problem is now Ruby, the language, is dictating the structure of our programs instead of just giving us the semantic that we are able to use to describe our computation, right? Dictating that structure, Jim Wyrick probably has some really fancy word for it, but I'll just call it coupling for one. Brittleness, right? It's also unnecessary, and I'll go one step further and say it's wrong. Ruby should not be this way. So the big thing about types is types tell you what you cannot do. Types don't tell you what you can do, they tell you what you cannot do. The compiler says you can't call that method on that object because it's not the right type. The compiler doesn't give you a long list of all the things you can do with that object. Oh, by the way, if you don't like that method, you can do this one over here. It doesn't do those sort of things. It says you can't do that, right? And like walls, people will either try to defeat them, go over them, bash their heads into them, that sort of thing, but they will create unnecessary structure that increases the complexity of the system. Complexity is what is the most important thing that we have to deal with. And often complexity will lead to pain. So I don't want pain in Ruby, and I don't want optional or hidden typing in Ruby. Refinements are, man, these damn slides. They're one of the leading proposals for 2.0. They've been talked about by Motts and other people, and talks about what's coming up in Ruby. And I think that they are the worst possible idea that I've seen get a great deal of attention after optional typing. Their primary purpose is to hide incompatible changes from you and from your coworkers and everybody that sees the code base after you. And they take something that is so important, naming, which is one of the things that we, with our minds, our ability to think, naming is one of the things that enables us to handle complexity more so than almost anything else. And it basically says when you're looking at this code and you see the name of that method, it could do something totally different than what you thought it could do because someone doesn't want to go through integration testing with their libraries. Even if we have refinements, we still have to have testing to make sure that the refinement stuff that they did is still compatible with something else that you do over here when you start putting together these libraries. So it hasn't taken away the need for that. We still need robust integration testing. And it does not help understand your whole program. It instead adds more complexity, right? More than anything, refinements suggest to me what-if programming. What if someone changes that method and I depend on it? Okay, you know what? If they change that method and it breaks your code, you either don't use that library, you fix the library, or you fix your code because maybe your code is actually broken. So what-if programming is really based on fear, right? What is going to happen if something happens? Or arrogance, I know better than you about how this should work, and I'm going to change 2s to return, the something else because 2s, why wouldn't it, return a string? That sort of thing. So the other thing is that refinements, I think, are an attempt to deal with this problem, and this is an honest problem. The idea that Ruby itself and the standard library has to integrate horizontally, right? Because multiple applications are going to be built vertically on it. However, any one of those particular vertical applications does not need to integrate. You can go do things that would break completely that application over there because their code is never going to live together. However, if you're going to make a library, right, it can't break Ruby. So that's the idea of the horizontal versus vertical integration. One more thing, -w. I think that it could be named that. Here's my problem with -w. So there's a big Twitter thing. You should turn on -w. Now, please do not misquote me and say that I'm encouraging you not to write good code, because I am encouraging you to write good code. However, I don't think -w is the way to good code. It's hidden in the parser. There are no Ruby objects that you get to mess with. It's fairly ad hoc. There is no programmatic control over whatsoever. You cannot tell it useless use of equal in this thing is okay because I wrote rspec and it's actually going to do something when you call that method over there. And it's really doing no semantic analysis. It's a couple of edge cases that it basically says, oh, I think you've got a problem here. Okay, so to reorient, right? We watched a video by the guy who's in charge of development at Twitter, one of the biggest users of Ruby and Rails in the world, and he told us that there are 4 critical issues that Ruby must address: garbage collection, concurrency, performance, and tools. I didn't hear him mention refinements. Ruby is basically bringing a knife to a gunfight. The world of technology is not going to sit around while we're happy about this wonderful language that we get to program in. So what are we doing about this? Here's what Rubinius is doing. We have generational garbage collection, true concurrency. The 2.0 work has been merged into master, whether you're running 1.8 mode or the 1.9 work that we're working on right now. You have true thread concurrency on your Ruby threads. Has a just-in-time compiler for performance, and we want to build tools. We're building the foundations for tools. So here's a little status update. Since RubyConf last year, concurrent threads are in. 1.9 features are coming along. We're running 1.8 and 1.9 on CI. You can check Travis and see how it's going. We're passing 36,000, some number of 1.9 specs. I'm going to work on encoding as soon as I'm done with this talk. Windows support is coming. The VM completely builds on Windows. It doesn't link the C extensions yet. That's coming. And Evan has been working really hard on just-in-time compiler improvements, which are going to take Ruby performance to the next level. The Rubinius garbage collector, real quick, it is a precise garbage collector, which simply means that every single place where an object exists in the heap, the Rubinius garbage collector knows that that's an object reference. It does not scan stacks looking for stuff. It walks up a sort of a parallel variable scope stack, so it knows exactly where to find all those objects. I think precision is something that's a nice feature in garbage collections. I mean, if we want to think of antonyms for precise, right, would we want one of those garbage collectors? No. It's generational. The young generation copies for compaction, and the key most important thing is that the garbage is never seen. Garbage collection is a misnomer. For copying compaction, you basically start with what object you know is alive, and all the things that object references you copy over here. You never see the garbage. So the fewer objects that live, the actual shorter the garbage collection time is. And we see 1 or 2 millisecond garbage collections in the young generation. If stuff lives long enough, it goes into the mature generation, which takes more time. But it's a great way to reduce the amount of work that's actually done. You're looking at small sections of the heap where objects, are most likely to die. The generational garbage collection is based on this thing called the generational hypothesis, which is that objects live fast and die young. Concurrency, fully concurrent Ruby threads. I can repeat that 700 more times. If you think that threading is not the way the world is going, you should probably go talk to somebody who's been writing or building hardware for the past decade, because they're going to many cores and they're optimizing those cores for running threads. Concurrent versus parallel. What we've built is the ability for Ruby threads to run concurrently. If your hardware supports it, they will run in parallel. Concurrent is more the idea that at any sort of step, things can make progress, but we used to have concurrency on single processor, single core things where you got your time slice and someone else got theirs. So just to sort of keep that idea clear, what you can now do is run your Ruby threads in parallel on your multi-core things. If you really don't like threads, there's a fantastic formalism called actors. They've been in Rubinius for a long-ass time. Now people are saying, I'm going to Scala because they have actors. And I'm like, what? I'm going to Clojure because they have actors. Okay, so we have actors. And then the just-in-time compiler is about making Ruby order of magnitudes faster, not like 20% or 10% faster. So an order of magnitude, like 2x faster or 3x faster or 5x faster. That's the point of the JIT. Order of magnitude faster. Okay, tools. Rubinius implements Ruby differently. And so everything I've set up to this point is basically to try to give you the reason why when I say this, it should make a difference, right? Rubinius uses Ruby. And that's a confusing thing, unfortunately. Like a long time ago, I said Ruby and Ruby, that's kind of the goal of Rubinius and that sort of thing. It's been very confusing to people. So what I want to focus on instead is that Rubinius uses Ruby to make a consistent system. If you write a C program that says 1 plus 1, C doesn't know anything about adding 1 plus 1, actually. And neither does Ruby, and it never will. C compiles to the CPU instruction for loading 1 into a register and loading 1 into a register and executing the add instruction. And that's the exact same thing that Ruby has to do as well. Ruby, though, uses a method send for plus instead, right? So Rubinius is not written in Ruby. If by in Ruby you mean I can go into the VM directory and read all this Ruby code. No, the VM is in C++, the garbage collector is in C++, the JIT compiler is in C++, although we're experimenting with some pure Ruby JIT stuff. But the point of in Ruby, or that Rubinius uses Ruby, is that the entire core library, all the things that you are doing in the Ruby semantics comes from Ruby code. When you go and use hash in your program, that's real Ruby code. And when the just-in-time compiler is looking at what's getting hot, it can actually go get that Ruby code, put it in your Ruby code, optimize it all together, and make it faster. But it's also the idea of the consistency. So instead of that RB object type, whatever, has to be numeric, right, which is sort of calling this way with a C function and doing some other stuff, we are dispatching through Ruby code. So you can actually subclass array or hash and see your methods called instead of something called out in C code where you can't fully participate. That's the idea of Rubinius. So a consistent system. Something like 1 plus 1 complex expressions, it's sort of like Ruby or C or anything else. It's sort of a tree. Way on the leaves, there are fundamental primitive things that have to be done, right? All the way when you get to the end, like adding two things together, can't be done in Ruby. So it's not in Ruby. How does Rubinius use Ruby? Well, there's this word. It's a pretty cool word. Homo means same, and icon means symbol. And homo-iconic means that I can take some Ruby code and I call 2AST on it, and I get back Ruby objects. So I can represent, so the Ruby code is a string, and these objects are also in Ruby. So I can represent Ruby as either text or as a data structure. I can do other things, like I can look at that a little differently. I can look at it as S expressions if I want. I don't know why you would, except they're very compact. It's nice, but I wouldn't recommend trying to process them to do anything useful. And you can just call it directly, so we support that as well. But 2AST is exactly what the compiler does. When you load your Ruby program, it runs essentially 2AST. So that's available. So this is the idea of the consistency. In Ruby, there's this idea of everything being an object. Well, let's look at some Ruby code. So everything's an object. Okay, so we're going to define a class. We're going to define a module, right? When we define the class A equals 1 is something runs that makes that happen. When you define a module, something runs that makes B equal 2. When we define a method, okay, that's what we're usually used to thinking about as where code execution happens. When we send a block along with a method send, then that block has some execution stuff too. When we write a Ruby script, we might do something right there, right? We might not be defining a class or anything. We just say puts hello. If you go into Rubinius and in IRB you do this, you get an actual object back from def, right? That object is a compiled method. If you were to run a script through our compile command, you get a compiled method. So a method body, a script body, a class, a module, a block, all these things are just compiled methods. So here we're going to open a class and we're going to define a method on it, attach method. Right? This is just all Ruby objects that we're dealing with here. And if we, here's the actual method for the class itself. That's where def m is actually going to get created. And we have a compiled method. Everything in Ruby that can do anything, right, is this idea of execution. And what we represent that as in Rubinius is a compiled method object. So the summary of all this is that Rubinius uses Ruby to build this consistent system. Everything in Ruby is an object. Everything that can do anything in Rubinius is a compiled method. And there's some really cool stuff that, that we're going to be able to do with that. So back to this idea, right? So next year, I'd like to say 2012, Ruby has the best tools, right? Here is my idea. So I'm calling this Nikita after the Rubinius agent. It's my idea of a tool, right? Go make your own idea of a tool. Now, I want you to write tools also. I don't want this to be like, well, there's like Rails, so nothing else is appropriate. Either use Rails or you don't. No. I want you to write tools using the foundations that we've built in Rubinius, but what I'm going to describe is one tool that I've been thinking about for a long time. The basic idea is that it's client-server. If I have Rubinius VMs running on the server, I here want to be able to talk to them, right? So essentially, I need to separate out the functionality. So there's going to be a client-server mode, and it has a completely separate GUI, right? So I don't want to tie Rubinius to some particular language binding. I've done desktop applications since the early 90s, and there is no end of pain trying to get Ruby to bind to some other thing, or you get these really horrible inconsistencies, like if you use like a Java library for like AWT. I mean, on OS 10, we're really, really lucky. Use it on some other platform where Apple didn't spend all the time to make it look good. It's really crazy. So we're going to use data as the binding instead. We're not going to do any language binding stuff. And finally, I want it to be very modular, but I'm not going to create a whole new system for modularity, right? Gem install. So it's going to be like gem install Nikita browser, and you're going to have a class browser, that sort of thing. So trying to keep it really simple. We have all those compiled methods. What can we do with them? Well, here's what we can do with them. If we put all those compiled methods in a database, then we start to blur the division between your Ruby program as source code and your Ruby program as a running program, right? As your program runs, the Rubinius compiler, the just-in-time compiler, the inline caches, if you saw Konstantin's talk earlier, we have objects where we're tracking all the types of things that we see. That information is easily extracted and can be annotating these compiled methods as metadata, right? So you can actually see not just what your, say, method call, what other named things your method calls, but actually the values that sort of come through, right? We can implement a class browser. You've compiled all your code. We can just go through this database of compiled methods, and we can find out everything, as you saw, about which methods they define, what other classes they're nested in. All this stuff is just transparent because the bytecode, the compiled method and the bytecode it contains is an exact replica of the source code, right? So we can create coverage and profiling tools. As your program runs once or twice or multiple times, there's this very convenient place to store coverage information. You could run your app in the test, and then you could run your app and do some real-like requests to it, and you could like look at that and say, wow, my tests are covering like 500 times more code than this application is actually using, right? And then if you talk to Michael Feathers, he wrote a really interesting thing about the carrying cost of code. What if you're worrying about testing all this damn code that no one is ever using, right? Then you might be able to like spend your time somewhere else. You can do bytecode instrumentation. That bytecode is just a stream of things describing something. You can actually get in there and change stuff around. And this is how easy that would be to do. So we have this kind of cool method called dynamic method. And what you can do is you can create from pure bytecode a method. And what I've done here is I've actually made this method that'll tell you its name. So instead of just printing the name out, I could instrument that bytecode to call some stat or tracking package and say, guess what I got called? Furthermore, these are my local variables. These are the arguments that passed in. Here, you can have a look at those as well. And it wouldn't change anything else that happened in that method, right? I've done it without like the tooling, just to like represent a proof of concept. But this is a very, very powerful thing. And Java, for instance, has this, so I think we should as well. AST transformations, sometimes a tree is a really handy data structure. And so using a tree, once you get the source code into AST, you can do all kinds of stuff. If you've heard of Heckle, I think Dan Kubb has sort of already prototyped a Heckle using a Rubinius bytecode, or either bytecode or AST. Almost out of time and almost done. Another thing we can do is better debugging. One of the challenges with debuggers, and I mean, if you talk to Tim, for instance, this guy right here, Tim Fogenschiff, working on maglev, he has some really cool stuff going on with the debuggers, right? Smalltalk has this great idea, like you're working along and you like fail, and then you like stop there and you do some other stuff and continue, right? Pretty neat idea. You have to be running though, right? So what I would like to do is explore ideas for debugging that span this blurred space that we would now make with between running and not running using that CompiledMethod database. Finally, documentation. I absolutely 100% adamantly detest documentation in my code. I think it's terrible. And the reason for that is that, one, it's very difficult to translate, right? So you have it in English. What if you want other things? Well, you extract it, and then you translate all that, and you do this sort of thing. It clutters up stuff. It's never usually the primary purpose of code is not to document stuff over there. So what I really, 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 really want is a fantastic system where the documentation lives over here and can be organized and structured, right? Structured for people to read, which is not the way that we necessarily structure the methods in a class or something like that, right? And very easily connect the two. So I really, really am excited about that. We can do analysis. Remember that -WTF flag that we looked at before? So we could actually look through this bytecode and see stuff like, this variable was used before it was defined. This is a really, really, really easy thing to do. And we can start adding levels of semantic analysis to it. We can look at, hey, you never even used this variable, or I find no method like this. Okay, but here's a problem, right? Ruby is a dynamically typed language, right? So what happens if you do module eval and you define something that doesn't exist syntactically, right, lexically, it's nowhere in the code. With the CompiledMethod database, we can say, you know what, I saw a method defined like this at this point in time. So this method I don't see in code. I see it was defined dynamically, however, so it's probably cool, but you might want to check that out. And then you can do all sorts of code quality analysis, right? And furthermore, you can build custom tools. I don't have all the ideas about how this stuff should go. I just desperately want us to have it, so please start building it. So the summary is, Ruby is at a critical point. I could be wrong. I could be the, was it Pied Piper or what? Anyway, the guy who's like saying, oh my God, you know, crying wolf, maybe? Anyway, I'm not trying to lead you off the cliff. And I'm not trying to cry wolf unnecessarily, but I am very concerned. I've been working on Rubinius for 5 years almost, and Ruby spec for as long, and watching things evolve. And so I want to give you my best warning, because I absolutely love Ruby. I work very, very hard to make Ruby better. I want you to note one thing. I didn't change anything about Ruby, right? We started Ruby spec in Rubinius to ensure that the compatibility among all the different implementations was as close to 100% as possible. So as Ruby developers, we didn't have to worry about where we're writing our Ruby and where we're running our Ruby and all kinds of stuff like that, right? I did not change Ruby. I didn't suggest changing Ruby in any way, shape, or form. I simply want to add tools and an implementation that answers the demands of industry. The stuff in Rubinius is available in 1.8 or 1.9 mode. And while I think it's great that we have Ruby 1.9 and I want to see more people use it, people bet, businesses bet on Ruby years ago. And what they had available is 1.8. They have applications in 1.8 and they don't necessarily have time to move them forward. We need to respect those businesses. They're part of the reason that so many of us can raise our hands today and say, I am paid to write Ruby. Finally, I don't want to be this person. I don't want anybody in this room to be that little kid inside upset that something that they find fantastically cool and may have changed their whole experience of programming or whatever, or may have like taken them from some other field into Ruby. We have so many people in Ruby who are not just, you know, marching out of computer science programs across the world, that sort of thing. So I don't want to be this person. So here's my plea to you. Please help Ruby help you. This is where you can find Rubinius. I apologize again for these slides, man. They look so good. Never will I use show off again. This is where Nikita stuff will work. Will be done. There's several other like directories, but you can go there and check that out. This is where you can find this presentation. Damn, show off. Thank you very much. And I don't think I have any time left, but I am very happy to take questions and talk at length about this. I leave tomorrow just after the conference, so please come say hello. Thank you very much.